Anyway, okay, hi. Yeah, so as Ed mentioned, I've had the chance of doing this presentation, I think around 28 different times around the country, but never here where I live, 15 minutes from here. So it's nice to kind of be able to kind of jump into this in the crowd that I know. And no, you cannot heckle John Humphrey. So, but before I get started, first of all, who here has some experience with radio production, radio engineering? You know, I know. So there's, okay, and although my focus is going to be on radio, there is actually kind of a lot of transitional elements to television audio as well. So some of the stuff's going to have some overlap. Some of it will be unique to radio. So, you know, if you have any questions, by all means, very casual, raise your hand, you know, stop me at any time. If I start babbling down the road somewhere, just kind of reel me back in. But first I want to tell you, I would say a little bit about me, but you already did. So, I mean, my background is in broadcast engineering and in radio, and also television production, but less engineering from a TV standpoint. So I started in radio right out of high school. So my background is radio. So I just was out of it for about 15 years before I joined Lawo on the radio side of things. So who is Lawo? I don't want to make this an advertisement about Lawo, of course, but I'd like you to just understand the perspective of the company. We've been around since the early 70s, started by a guy named Peter Lawo, and now his son Philip runs the company. About 300 people worldwide, about 30 people in North America, across offices in Toronto, New York, and LA. This is one of our earlier audio consoles we made, and you can't quite see it here, but there's a whole rack, a whole card sitting here, and that's a very analog, discrete component, old school thing, and that's only one channel of audio. It's stunning how this stuff has evolved over the years. But you know, we're mostly popular in Europe. We started making stuff for broadcast audio folks in Germany and then grew that to Europe, mostly public radio. But now we've become very much a global company. So anyway, real quickly, just so you know the kind of the scale when I talk about global, I mean, I've done a few Olympics, and sadly, now that I've left the Olympics, they're starting to use Lawo gear, which is like, oh, darn, because the stuff is really solidly built. ESPN, QVC, Turner, NPR, you know, I don't have NEP on this slide, which with you, I know with you in the room, I should, yeah. But we're grateful to have some really neat customers. So we've been around a while, is my point. Kind of an example of some things that we've got at ESPN Bristol, Connecticut. There's 4 of these consoles. QVC has 4 of these consoles in the other side of the state. NPR uses some of our audio traffic, well, the whole infrastructure is our stuff, but also some neat technology that actually analyzes audio circuits coming and going, and it matches up against a traffic system. So if there's dead air, it's not booked for traffic, that's okay, no alarms go off. But if it's supposed to have traffic on it due to a booking reservation and it doesn't, that's when the alarms go off. And we have synthesized speakers in the ceiling of the engineering space, so they immediately hear the alarm. They don't have to go to a computer and see what the problem is, they hear it immediately. So we're kind of into that. We're German, typically kind of obsessed about workflow, and so that's where that comes from. And then this is actually here in Oregon. Ali, the head of engineering for University of Oregon in Eugene, Oregon, KWVA. So we also do small stuff too. And this is just one really cool thing about NPR. If you ever listen to their headquarters, this is one big sheet of double pane glass between the main production studio and the talent. It's beautiful. Once you're sitting right there, you feel like you're in the same room with them. It's pretty awesome. And that's like a whole MADI and what's called AES-67 or Ravenna audio over IP infrastructure there. It's a blended infrastructure. And we're going to kind of get into that now. So that's real quick. That's kind of our background. So virtualization, right? You've all heard the term probably. I mean, a great way to ask this question first is, does anyone know the actual physical address of your email right now, where it's parked? You know, if you want to knock on a door and find a server, do you know any idea? So not too many people have a server under their desk, right? That's because it's virtualized now. It's not just in one place anymore. And so you could have copies of your email in a replicated server that could even be off this continent, and you wouldn't know, and hopefully you don't care, because it just works. The IT world has long time figured out that using computers in a virtualized environment allows them to scale things more quickly, migrate more software updates more quickly, usually more reliably, and centering really on mostly Windows environments or Linux and Unix using commercial off-the-shelf hardware too. It's just cheaper when you buy something that's already mass-produced as opposed to making it individually yourself for most companies under most applications. And so those are things that kind of work in IT. Do they work in radio? Well, the guys at Lawo have been the guys and gals have been kind of thinking about that for a while. This is a typical reel, couple of racks for audio processing. Now this one actually is from a recording studio, so you won't recognize some of this from a radio standpoint, but I mean, you've got your patch bays there and discrete boxes for all kinds of different, and gates and compression and encoding and equalization and parametric equalizers and all kinds of other digital signal processing. You may, if you're in radio, you've got boxes for codecs and telephone interfaces. The list goes on. And think about each one of these has a power supply or two. Each one has a bunch of discrete cabling, either analog or digital, between them all in the patch bay. Each one you had to buy off a box and take it out from UPS and take it out and put it in your rack and install it. And a lot of these, especially if they're digital, they're already running an operating system on it, some sort of embedded operating system. So again, we started looking at all that. There's a lot of waste there. And things could get more efficient if these boxes become what are called applications, and if you start to trust this little RJ45 connector a whole lot more. Because we're talking mostly audio over IP, which therefore travels mostly over Ethernet. And it's really the whole concept of digitizing audio from the microphone all the way through to transmission or to the speakers. So once you packetize your audio, you can do a lot more with it, as we'll get to. So any questions at this point? Any thoughts, comments? Nope? Okay. Now, kind of as a corollary, I should say that let me kind of draw an example. We've done this before. All right, so your monitor has an AR clothing on it, so that's not going to work. So I'm going to point. But some of you are probably already ahead of me on what you're looking at here. I mean, cameras, telephones, cute little rotary phone, VCR, GPS unit, Rolodex. Is that company still around anymore? A dictaphone, a camera, a compass. All these things are, well, now we have them on our phones, and they're called apps. So we've already seen a lot of physical boxes migrate into one really powerful box. And good luck finding some of these things anywhere but eBay anymore. So, and the other cool thing is when you're running these various applications on your smartphone or on a computer, you have access to what's called metadata through that information. Like you tag a video and you email it to somebody. Well, they've also got the metadata where that came from as far as GPS locations. Or you edit something in an iMovie on your iPhone, and then you edit it, you're finished editing, and you can upload it to 3 or 4 different cloud servers, all from your phone. And of course, when you see somebody in your Rolodex, you tap the number and boom, it's calling them. So, there's a lot of impressive sort of efficiencies when you combine all these virtual applications on one hardware box. And so you kind of see that's where we're going. And in fact, that's, is that a Windows or a Google Pixel? I used to have a Windows phone on this. I took it off because I read their sales data. It's like okay, all right. So, anyway, so if you're in radio or if you've been in radio, you kind of remember the world of vinyl. Well, actually, you've got turntables over there, right, Russ? So and I was just, the hipsters are bringing it back. So, yeah, they are really, yeah. With not kidding, Audio Technica in Stowe, Ohio, right? The U.S. headquarters is just across the way. I was there last summer, and I was walking by all these turntables, and it's where they do the repair for the U.S. And the thing is, they got Bluetooth turntables now, and of course USB turntables. I mean, that's so cool and crazy. But anyway, but there used to be things called carts, which were like little 8-track tapes you pop in a machine, and the little pinch roller or whatever that capstan or that thing pops up, and it plays real instantly, quickly. Of course, CD players, mini disc, RDAT, ADAT, all kinds of different formats. And somebody once realized, wait, we can digitize this audio, and then why do we need all these boxes? Why do we need all these reel-to-reel tapes and stuff like that? And so somebody realized, okay, and a lot of people realized, we can digitize this and make all these different pieces of hardware audio applications. Take all the audio from the cart machines and so on, and all these other sources, and put them onto a hard drive. And then when you're running it onto a Windows machine, or again, we're really fairly agnostic on OSs, but Windows or Linux or Mac or whatever, these same type of machines can be used for audio production. Lots of great editing tools now. I mean, who actually edits with razor blades, right? I have this theory that, and I'd love to know the research of how many radio stations used to buy razor blades, and now that with everything's digital, the sales have plummeted for razor blades and Band-Aids also, right? Who's buying Band-Aids at radio stations? So And of course, computers using for automation, because I know when Russ goes home tonight, and especially on a Friday night, no one's going to come back for a couple days on the ESA side of things, right? Except for those two guys' Saturday nights show, which is a fun show. And of course, logging. Keep the FCC happy. You've got a machine in there somewhere probably running logs of your transmission equipment. So, you know, software's already kind of taken over for a lot of hardware. We just got to think about where does audio go. One of the other things that's happened in parallel is CPU processing speeds have really sped up. I mean, just a few years ago, a Pentium 4 was the fast machine out there. But now we've got like an i7 on this thing, and it's so much unutilized capacity. You can actually do a lot more with a computer now than you generally could do a few years ago or generally need to do, especially with audio. Video's a little different. Video takes a lot more processing time and so on. A lot of these trends I think you see start with audio and then migrate to video as the technology can adapt to it. So taking what we've just talked about this dematerialization of all these hardware things down to virtual apps, let's kind of deconstruct a radio studio. And I'll kind of go detailed for some of you that haven't been in them. But generally, of course, you've got microphones, you've got headphones, you've got speakers. That's kind of like the analog world. You've got sound cards of some sort that get audio in and out of a computer, right? And usually if it's a large enough computer, it's a card within it, or it could be like in a USB external interface, something like that. You've got a mixer or a console or a surface. They've all kind of, if I use any of those names, that's really what I'm referring to. Because these days, modern mixers are just basically glorified mice. They're just control surfaces. Really huge consoles, and they have like a little Ethernet connector on the back. You know, that's just telling a whole other thing what to do elsewhere. You know, so but again in radio, and no doubt Russ has got a few back in there. Telephone hybrids, codecs for remote connections with other broadcasters or guests. Voice processing, stream encoders, so you can listen to WYEP and WESA on your phone like I do every day. And air processing, of course. So these are hardware elements. And how do we virtualize this stuff? I've got some examples coming up. But these things, like you kind of get this routine here of what I'm saying, these things now themselves have to become applications. They have to become something that's running on a box, that's running an operating system that was made for a lot of stuff other than just the broadcast world. And you just kind of like take these boxes and put them on eBay. So I'll walk through the next stage here. If you've got these applications that have replaced your hardware, and you still have a computer in your studio, that's the key thing. That's not going to go away. Another thing that's key, these analog devices, microphones, headphones, and speakers. Until we've digitized all our inputs and outputs to our head, we're still going to have this stuff. So what's pretty cool how the technology has evolved that these things are digital right up to the diaphragm for the mic and the speakers. But you know, still we need those little analog interfaces. So here, popping forward, we have a computer now that we've got these applications running on, right? I mean, you can be doing encoding on a computer. You can be doing processing. You can run telephone codecs on a computer. You can have IP connections to remote broadcast facilities on a computer. You know, but you still have to have an analog outside world. One little caveat, when you talk about digital audio processing in a hardware-based environment versus a computer, the computer's still not fast enough to do it without a little bit of delay. Now, if you guys were in radio right now, I would say, how many people listen off the air? And no one would raise their hand. Except in Oklahoma a few months ago, somebody did. I'm like, how do you even do that? They have an analog system, full analog, very old school analog radio station, and they could actually monitor off the air. But nowadays, nobody does. It's because with the HD encoding especially, there's just seconds and seconds, dozens of seconds maybe of delay. So, but the host usually can tell beyond more than, well, I don't know, Russ, 10 or 20 milliseconds maybe if they're really good, something like that. I mean, I know that different hosts have more sensitivity to delay in their ears. So if you're using a sound card to interface from your computer and you're doing some processing in that studio, between the microphone and the speaker, you may want to consider getting rid of that sound card and using what we might suggest is like an AES-67 interface. There's different types of AOIP infrastructure, by the way. There's LiveWire, there's WheatNet, there's CobraNet. We're big fans of AES-67, which was the defined open specification by the Audio Engineering Society, hence AES. It maximizes your interoperability between different vendors, hardware platforms, and software environments. So that's why I keep saying AES-67. If you've heard the word Ravenna, that's actually not Ravenna, Ohio, which there is one. But it's an extra layer on top of that has more capabilities or controls, but AES-67 is the root standard. So I highly recommend you always kind of, standards give you the most opportunities to mix and match hardware. But anyway, if you're running a sound card on this computer, what's called a virtual sound card, and that's how you get audio on and off a computer in an IP environment, you can say goodbye to your physical sound card because you can run all this audio through software right directly over the Ethernet connector on the computer. So, and 64 to 128 channels are no problem over Ethernet, depending on the bandwidth on the Ethernet, the routing. It's all gigabit Ethernet that you would need to use for this. But one more thing about the AES-67, you may want to consider, like I was saying a minute ago, is a low latency way of monitoring the audio in your studio. Like this box here is kind of a little multi-purpose box with AES-67 Ethernet, 4 mics in, 4 powered headphone outs, balanced and unbalanced audio out. It's kind of like a small studio jack of all trades thing. The thing is, it's got CPU or audio processing in it that allows you to replicate the delays of what's being created on the computer in the hardware environment more quickly. So your hosts don't have that slower lag time that you might get running through a Windows or any kind of PC that's doing audio processing. So not to get too far down the rabbit hole, but just consider it's not perfect yet. When you're doing audio processing on a computer, there's going to be a little bit of delay. So it may bother some hosts, may not. Any questions on that? Kind of bouncing around there. I mentioned the guys in Stowe, Ohio, Audio Technica. This is something, when I was out there last summer, that it's a little scattered here, but just kind of work with me. This is just what we set up there. And what they wanted to do is do some interoperability testing with a microphone. They didn't tell me they wanted to do this, by the way. It's always interesting when you go to try new technology and you don't test it first. But they showed me this microphone. At the time, it was the only one that exists in the country. And there was only 2. The other one was in Japan. Instead of an XLR connector on the back, it's an RJ45 connector on the back. So as soon as I thought, oh, geez, this is going to be cool. So I plugged it in. I literally had a $20 Netgear router with me, or switch. So I plugged it into that, plugged it into my laptop, sparked up the software, and because it's AES-67, it knows to look for audio streams with the right protocols. So it saw it immediately. I patched it as a soft patch into the mixer and was immediately able to bring it up. And the other funny part is that they asked me to punch in an IP address into my web browser. And I did, and up came an Audio Technica branded kind of interface. And I thought, wait a minute, I'm not on your network. How is that working? And then I said, wait a minute, is it? And they said, uh-huh. There's a web server in that microphone, too. So that's really cool. You can change a bunch of parameters in it and stuff. And that's just, wow. And that changes things because you see that ring around it's lit blue. Well, if that was a polychromatic LED, you could change it to a different color, or you could strobe it. If you tell somebody in a big room with a lot of mics, go to walk up to that flashing microphone, well, you can't do that today, or at least not nearly as elegantly. So anyway, that's what interoperability is kind of that plug and play kind of stuff. And also that's telling you where microphones are headed. Because one day you're not going to have in a studio a bunch of mic preamps. You're going to have, whether it's, Dante, like I said, or some of those other standards, you'll have some sort of connectivity directly from that microphone into a switch. And it's going to be the same switch that the entire plant is connected to. And whether you're routing audio to the studio next door or to the studio literally halfway around the world over a VPN, it doesn't matter. It's just IP data. It's just. And there was a power switch? No, it was they had an inserter between that and that, a PoE power inserter. Yes, yeah, because this switch, that little cheapie does not have PoE. Right. So good question. For all those who don't know, PoE is power over Ethernet. It's a current limited way to supply power to different hardware kind of. I mean, it's not too. This whole box runs over PoE. So it's a pretty good current drain, and that holds up to like 2 or 4 different 48-volt supplies for phantom power too. So you can get a pretty good amount of current over that. I don't know exactly how much, but some of you all might know that. In fact, in your networking class, you might have picked up on it. Oh, okay. Right. And there'll be a test on it. So that's a little diversion into audio packets and where audio is coming. And also, some of you probably know, like companies like Genelec they make studio monitor speakers that have AES-67 Ethernet ports on them too. So you can plug your studio monitor into the same IT switch as you're plugging your microphone in. And of course, your control services and processing, it's all IP at that point. So why virtual and radio? This is going to sound a whole lot like IT, right? It's dynamic to a changing workflow. You can completely redesign or rebuild the virtual faders of a mixer on a screen at the tip of a hat, on the hour clock. So let's say some shows are set up for a bunch of mics in a studio. That's one type of setup, one type of preset. And then you've got another show with 3 mics and a playout system. Well, no reason having all those other mics. They just confuse the operator. So the next hour that board resets and those other mics go away. It takes away the stuff that gets in the way. It declutters the work environment when you can customize the software and the mixing environment to what's being actually needed to be done. I mean, George's NEP, their consoles have so many faders. That's double banks of faders even, right? That takes a really skilled engineer to operate that. The problem is in most radio studios, engineering is sadly on a decline as far as available engineers to actually run a board for a show. So some stations don't even have full-time engineering staff at all. So good luck finding an engineer, especially in middle and smaller markets, to actually run the morning show. It's harder. So the simpler the technology, the easier it is to get the show done securely and safely, without issues. Software apps are definitely more flexible. If a vendor comes out with a new software app, I mean, how many times are you going to get app requests on your phone, right? If you got some broadcast mission critical stuff, you probably aren't going to get updates every week, at least let's hope not. But it is easier to upgrade if there's a new feature in a certain processing tool or codec there's a new codec that's come down. It's so much easier to just do a software update over maybe an internet or even a USB stick than it is to upgrade hardware. Reduce cost and complexity, certainly. There is some learning when you go to IP audio, but it's actually pretty simple, I think. And so reduce complexity certainly to the operators too. The beauty about computer screens is you can take away all the clutter of stuff you don't need when it even comes to engineering setting things up. So, again, commercial off-the-shelf software and hardware are what we're talking about as far as keeping the cost low for a computer that's running some of these software products. And cloud architectures, which we're going to get to. And how am I doing on time? I feel like I'm lagging here, but okay, cool. Any questions before I go into some cloud architecture possibilities? Nope. Okay, great. So I'm going to show you 6 examples of real-world applications that are out there now, and covering these different types of applications. And for some of you who are not in the radio space, I should explain real briefly what a codec is. Historically, one type of codec has been like an ISDN codec, where you connect one studio to another studio over a nice quality 64 kilobits per second line or something like that, or 128 or something. Excuse me. But ISDN really has always stood for it still does nothing. So it's never, so it's waning. IP codecs are getting much more popular. Different types of encoding algorithms that you can send multi-channel audio both directions over the public internet. And I used to do a lot of freelance broadcast engineering where I was using both. I literally would have in front of me ISDN and IP codecs, and the IP codecs are just so much easier. And by the time you set up and connect to a customer worldwide, wherever they are, as soon as you let go of the mouse, you're already connected, and it's solid. ISDN is, there's still ISDN out there, I know, but it's getting harder to find, and it's not quite as reliable. And of course, there's other, you can use codecs for even connecting over like dry pair, I suppose, or something. But telephone apps, phoner apps are what happens if you're listening to a live show or recorded, and you hear people phone in for an interview. Well, they're using a phone interface at that point, a telephone hybrid. What a hybrid does is it converts from the telephone public switch telephone network to an audio signal that's useful in the broadcast studio and bidirectionally. So processing, there's all kinds of stuff for audio processing that depending on the music format or voice format, different ways to process audio. Different hosts have different audio processing curves, so that when a host sometimes sits in front of a mixer, you can call up their specific curve that makes them sound a certain way on air. It's especially useful, like really loud rock stations might do that, a little more than public radio might do that, but type of example. Streaming apps, you can imagine that's how you get audio from your program or secondary audio channels in your studio to a streaming replication service like a Stream Guys or other companies like that are out in the cloud. And they're the ones that do the heavy lifting of creating that stream that then thousands of people can hit simultaneously. Some stations also host their own streams internally too. Right? So console apps, that's of course mixing the audio, and virtual sound cards is what I was mentioning earlier about how you can get audio on and off a computer without using a physical sound card, but in fact just flowing it over IP. So codec apps, what I'm about to show you are 6 different examples of software you can literally download today that are real live with real paying customers worldwide. So these aren't fantasy things. These are only going to get better. This product made by a company called Source Elements is called Source Connect. And this one over here is called Audio Compass. They are, in fact, like the replacements of what might be called a Comrex Bricklink, if you've ever used like some of the IP codecs, building your not in the head, yep, which is a software way of getting audio through a computer over the public internet to another computer at the other end. Great for broadcasters who are doing remotes. You know, just if you've got a computer at the remote site and one at the main studio. Some of you, if you've heard of Luci Live, L-U-C-I, that's a really nice, really sophisticated IP codec that runs on an iPhone, and it also connects back to your main studio to get audio back and forth if you're doing live hits. And these things are really, you can get a lot of audio through these things because they're made to work on really low bandwidth or iffy bandwidth kind of connections out in the field. Video would be harder, but now this is cool. A company in UK called Broadcast Bionics makes this. This is a 6-line, and they also have a 12-line now, telephone interface. The thing is, most phoners in a studio is something in a rack, right? And there's like, you know, 6 or 12 phone lines that you're paying the phone company for, and they're all connected in the back of it. And then in the studio, you can control which lines go on the air. This thing requires no connectivity to any kind of hardware in your station except for an IP connection over the internet back to their cloud site. They're the ones, or other companies that they can recommend, are the cloud service companies that do the connection between the public television, or the public PSTN, Public Switch Telephone Network. That's always hard to say. And what's called SIP, I should say. SIP is the protocol that gets audio over, for instance, Skype. Skype is an SIP telecommunications product. When you use Skype, you're talking to somebody. If you call somebody on their cell phone or something like that, or a landline with Skype, you're using somebody else's cloud-based service to make the connection between your IP-based SIP connection and the public switch telephone network. That's what this does, only up to 6 or 12 lines. And the cool thing is a producer can see this. You can, let's say you have a host in radio that broke their leg and they can't come into the studio. Well, they could actually screen and take calls while they're at their home studio, because all you need is an IP connection back to the internet. And so that's pretty cool. This is even cooler. This thing called Stereotool, there's a guy named Hans van Zupten who wrote this thing. This has got many different digital ways of massaging audio that runs through it, but one of the cool things it's got is something called a declipper. You can take really squashed audio, I mean like really almost like square wave looking audio, and this thing somehow figures out how to put more dynamics back into it. It's just amazing what you can do with digital products now with the fast CPU especially. If you're into radio, you know there's a couple of big main signal processing or on-air processing makers out there, manufacturers. One is called Omnia, and they've licensed this to use on the air now. So another one is Orban that we'll get to in a minute. So there's actually broadcasters that are running through this software now live on the air all the time. And now I've mentioned Omnia. This is Orban, Greg Orban, who I think it's Greg. Anyway, this guy has been a radio veteran for many, many decades. They used to make real big hardware-based processing gear, and now it's gotten a little smaller, but still mostly hardware. They also have this, if you notice, this is a Windows-based application right there. This is this would run on, is running on a dedicated computer in a broadcast environment, last step before it goes to the on-air, you know, to the transmission. In processing for radio, this is kind of a big deal for especially competitive like rock stations and, you know, heavy music stations that need to sound louder than anybody else, or other kind of audio heuristics and stuff they can do with this. You know, if you're listening to public radio, you know, music or talk, there's not a whole lot of processing. There is some, but it's not as crazy as some real competitive stations, right? Not anymore. Okay, right. It depends what mood Russ is in. So anyway, so that's a perfectly good example of a Windows box running full time right now, keeping stations on the air. This one is a company out in California called Modulation Index makes this product. It's called Streams. It's a multi-HLS stream encoding application. So you drive audio into it, and then you tell it what service providers you're using out in the cloud, and then it will create, because with audio you can have all kinds of different bit rates and frequency responses to the sampling that you're doing. So depending on what kind of streams you want to make available to your customers, you create it here and you send it out in those different formats to the stream encoding company. And it can do all that at one, you know, at the same time. This happens to be what is known as virtual radio mixer by a company I know about. And this is a multi-touch environment where you can actually control all these faders at the same time if you want. And it's software-based. All these labels can be changed on the fly or as the shows change or dictate. You can route audio to different audio buses. These meters stay live. You can minimize it with hitting that button, and the thing shrinks up except for the meters, so you still see your timer and your clock, but or your meter, but that still gives you full access to the computer environment. So you could still have like playout software running on your computer, or doing Facebook posts or Twitter updates, whatever you're doing. The cool thing about software, you can get, if you don't want it, you just get it out of the way. Right, and just in case there's anybody watching Star Trek's evolution into the touch, I mean, back in NCC 701D, the Star Trek Enterprise from the 90s, even there they had those touchscreen kind of, the consoles and the bridge and stuff. That is B right there. That is B. Oh, brilliant. Excuse me, brilliant. That wasn't very funny, was it? Yeah, no, thanks. Groaner. Anyway, but multi-touch isn't just for Star Trek. It's actually real. This is a company called. This is made by a company called Waves, and it's called the LV1. Yeah, eMotion LV1. It's a front-of-house live audio console that, as you tap, depending on how you configure the software, you tap a fader and up pops the full GUI for that channel. Equalization and processing, if you have any, set up for that channel. Audio routing, what buses it's going out to, stage monitors or what have you. Any kind of looping that you're doing through processing. And then you let go, or you tap it again, and that goes away, and then whatever's your default setting for that other monitor can be, destination monitoring or who knows what. And it's all software. I mean, the thing is, if you spill a pop, or east side of the state, we say Coke or no soda. But here we say pop. So if you spill a pop into this console, oh darn, you got to get another monitor. If you spill a pop into a real physical mixing console, you're going to have a problem. So so this is real. It's real shipping products. This is an example. When I talked about virtual sound cards, this is an example of what one looks like, where you can take audio from different bidirectional audio device drivers that are running on the computer, which is kind of like a virtual patch cord to get audio from a playout source into a destination source on your computer. A simple example would be like in Skype, when you got to select what drop-down for what microphone. Are you using the mic in the laptop? Are you using your headset mic? It's that kind of thing. Although these would, when you install this, 8 more of those would show up, and it allows you to route audio around. So this is the gateway from your computer to the Ethernet connector on it. And that's, it's very simple. It's just basically setting a lot of drop-downs and creating different streams of AES-67 going out and picking up streams coming in and routing them into your computer. And one more thing about AES-67, if you guys, some of you who aren't familiar with it, is that it really is streaming audio. And streaming audio sounds sort of consumer, sounds sort of like Yahoo or something, or YouTube, I should say, not Yahoo, YouTube. But in this case, it's streaming, but I think about up to 64 channels on gigabit Ethernet, up to 128, all at the same time. So, and really fast. This is another tool that is kind of an example of the virtual sound card that allows you to also engage different processing and routing and monitoring applications also on the computer. So with this kind of tool gives you more control of audio routing right on that one box before you even send it back out. So that's kind of a key part in knowing that you can do so much of this stuff already with software on a computer. And so now looking at these tools, any questions at this point? No? Okay. This is kind of almost like review already for some of this, like the streaming server. If you're sending out, you can have one dedicated machine right here dedicated to sending out these audio streams to your streaming replication service. And you've got audio going into it, maybe from AES-67, but that computer can just sit and run all day. And of course, that's not going to really max out its CPU either, probably not, depending on how many streams you're making. So keep that in mind, that a few of these things could be running on the same box at the same time if you want. Another example is if you're, yeah, John.
What was HLS?
It is a streaming encoding format. And it is, there are many, and it's one of them. It's an acronym, all right, that I don't know what it stands for, but so if anybody else does, So now here like, as I mentioned, like in certain radio production facilities, different hosts may have their own audio kind of sweetening for their voices and stuff like that. You can have a box dedicated to doing nothing but processing. And instead of having 3 or 4 or 5, parametric equalizer boxes on a rack, you could have all of those happening at the same time on one instance of an operating system on a rack someplace. So you're starting to shrink it down. And much less expensive. And again, because it's software, you can dial up different presets throughout the day or throughout the show as you need to. And kind of one other thing I should mention here, remember all these things are running on a computer-based environment. You notice you're not seeing a lot of, some of these you see screens and GUIs for, others you don't, but all of it is accessible via a GUI. So if you're an engineer and you want to go change some of this processing and you're at home or you're on the other side of the continent or the planet, you can do that remotely. Just remote in through hopefully a couple layers of security, right? And then you can make these changes. You don't have to be in the studio. Because it's software, you can access all these parameters remotely, which does create certain important issues when it comes to data security, right? Because you got to architect your system properly to keep the bad guys out. Here's kind of an IP codec server. Let's say you've got a couple of reporters in the field and they're running Lucy Live on their smartphone, or maybe like that other Source Connect application. Well, this thing could host multiple instances of audio codecs at the same time. And that again, you can do now. You can run multiple instances of those applications. Here's kind of a neat thing. This picture, I almost don't like showing it because it's already awkward looking at it. Because there's a computer and there's a computer. And it's like, wait a minute, why are there 2 of them, right? So like here's one that's dedicated to some playout for like Enco. They use Enco here, but Enco is one of a few different companies that are, if you hear me say it earlier, it's playout software that has replaced the cart machines and reel-to-reels and stuff like that. But audio processing, that's on one box, and then you've got the mixer on the other box with a little more processing. But you can combine all of that together. And notice you're connecting to maybe some, again, I/O box in the middle with some analog interfacing for your studio. Maybe you're doing a remote and you've got a little box like that out in the field. But it makes no sense to have it as 2 separate computers when you can do it all in one box. So in this environment, in this example, this could be like something like running Microsoft Surface, which is a real world example. It really works, and these products I've shown you really do work on it. And with one connector, you could be sending your HLS streams out to your encoding service providers, and at the same time locally routing audio to an audio interface box that you've got for interfacing to the local speakers and microphones and headsets in your studio. Which really gets fun because you start realizing that could be a fly pack, that could be a disaster recovery kind of solution, that could be something that you leave at your transmitter. So if your main studios go down for some reason, a hurricane comes through, and the thing is your host can have this, it can be on anywhere they want over the public internet. If you're in Florida, you've got issues right now with lots of data issues, and is your internet even reliable, even if you've got it? But if you could send a couple of your hosts to a few states away, I'll back up a step because you all may not know this, but a lot of radio stations have IP codecs as their backup to their transmitter. A lot of them have STL or studio to transmitter RF links as their main link, and then others have like dry pair or leased lines to the phone companies, but others use IP codecs as their background or backup, and some even use it as their primary link. So all you have to do is, originate from a new destination or new source, an IP stream to the backup and switch to that. There's a few ways to architect it, but yeah.
You say this is a real world application?
Yep.
I'm confused. It looks like that there are 2 separate IP connections.
So coming out of this, you would have to use like a switch, to have something that connects to the public internet for the streams, and then connects, like in this example, to if you were to use this box, so you can connect to that. Because you won't find a tablet with 2 Ethernet ports on it, probably. So, yeah, that's add a little $20 switch, then you're good. And in fact, oh, geez, that's not an advertisement. How'd that slide get in there? All right. So actually, I will go back a step because it is kind of neat to point out that this stuff, you literally can fit a whole radio studio in a backpack. So one little sidestep to all this that virtualization also allows you to do is do mixing for you. There was a guy that came up with something called, his name is Dan Dugan, and his company is Dan Dugan Designs. And he came up with a really cool thing a few decades ago called Automix. And it's a way a digital mixer, not analog, but a digital mixer looks at all kinds of audio sources coming in each one having a priority setting as far as what matters more versus less, and how to sum all that through an automatic mixing engine and to get a constant gain level on the output of it. And I say output, I'm to my right, to your right over there, right? Output over that way. And then, so this is a radio station in Sweden called, well, they're Swedish Radio. It's their network, kind of their equivalent of our NPR or Britain's BBC. And they're using Automix completely in their main studio. If you notice, there's no faders in there. This guy is on the air. One console is his touchscreen GUI. And this console is, actually it's not a console, that's just a computer monitor for email and Facebook and Twitter stuff, news feed, stuff like that. And I love it, their on-air light isn't red, it's green. It's very peaceful, In an example of what he's looking at, this screen, whoop, whoop, whoop. I need a virtual presenter here. This software product, which is called VizTool, is embedding this environment, which is from a separate playout traffic system in their studios. And the way it works is that if you can see his thumbs are poised to hit little buttons right here. And it's all touchscreen, of course. And when you start playing your audio, it'll light up and it'll give you a countdown, like in this case, 3 more minutes and 18 seconds before that piece is done. And with Automix, his mic is set up on a higher priority. The playout, well, maybe a guest mic, first of all, might be a little bit lower, and then playout could be lower yet. Maybe jingles come out from one server that has a different priority than commercials, because you don't really want to talk over a commercial. Advertisers don't generally like that. Right? And so it creates a really automatic environment where he talks naturally, the things that are allowed to come down below his voice do. Imagine during political season, you've got 5 people or 6 or 8 people around a board or a table, and they're all talking fast and furious, and you have a moderator that's trying to get their voice in there to quiet everybody down. Well, if the moderator's on Automix with a higher priority, that happens automatically. So, and you can adjust the attack and delay as well in the product. So. This is really kind of, for our company, a real concept of it's, the audio studios that we're so used to in television and in radio had physical consoles, they still do. But do you really need it? Or is that just the way to get to the, is that the means to the ends? And is the ends just flowing and mixing audio? And if that's the case, then what you really need to do is consider focusing your environment on what the host needs. Because notice, he's also the host. I don't know if it's real obvious, just because he has the mic doesn't mean that he's the host, but he is. There's no engineer. He's doing his own show. So,
his mic is that headset?
Headset mic, yep.
Is it any good?
I mean, some people have actually, is it a Bear dynamic or is it a, the other thing is somebody told me that is actually on a belt pack. And I don't see the belt pack in the photos, but I mean, that makes sense. If you don't mind replacing batteries, that's somebody can walk around their studio with a little more comfort. If you've got a few guests, you can kind of just have conversations with them like this and throw this whole podium thing out of the way,
Sounds far better than a lot.
Yeah,
I mean,
yeah.
sportscasters use those, so I guess they're pretty good.
And the other thing is with audio processing, you can somewhat make up for that, although purists would say that's not a good idea. But,
That's what I was going to comment on. It seems like with the processing that you have available, then it doesn't matter the quality at that point.
Well, that's an interesting way of looking at it. Yeah.
But there is a point where you can make up for that, the lack of low end,
That's out here that's talking.
It's digital. What could possibly go wrong? So anyway, and I love showing this slide because it's disruptive, because it changes everything when you have an environment like this. But, so kind of, I'm getting close to a recap here. Any questions, any comments? No? Okay. But so just kind of imagine this environment here where you're doing your mixing processing, maybe your playout codec, stuff like that, phone codecs, hybrids, on a local mixing environment that's altogether built into a touchscreen interface. You have a wide area network to a central server system. Maybe your playout is actually hosted over here and you're transporting the audio back and forth over WAN. Maybe it's down the hallway, maybe it's across the world. Imagine that something like this, all these different applications and EQ settings and all your playout libraries running on Amazon Web Services. Maybe they're replicated off different AWS servers around the country. And of course, if one goes down, you've got live connectivity to the other one. It gives you a lot more disaster recovery, and it reduces a lot of the big iron in your studios, and you start being able to do things more mobile, maybe more remotes, more people broadcasting from home. Oh gosh, it's every 2 or 3 radio stations I visit, they look kind of like here, like a ghost town, except even during the day. And it's because they have hosts creating content from their home offices or frankly their bedrooms, who cares? You know, wherever they have a microphone. And you know, it's funny, when I used to do videos, I would actually have a walk-in closet and I would do the voiceovers in the closet because there's, you know, clothing all around, it absorbs your sound. Yeah, it wasn't that,
Light in the closet?
well, it's a small one, but yeah. So, you know, yeah, okay, so the cool thing about this is you could have talent producing their own shows, and instead of switching from studio to studio next to each other, you could be switching from the offices in Washington, you know, Washington, PA, or Washington, D.C., or Washington State. And it really doesn't matter. It's just all IP flowing around on a virtual private network that you have running over the public internet. So, and you worry about connectivity. Well, most stations require connectivity anyway. Not just internet, but they require connectivity to their STL or through their STL to their transmitter, and certainly their phone lines coming in. So, yeah, it's one more thing to worry about, you know, going down. But then, you know, ideally you have a couple of ISPs coming into your building, and you have some resiliency there. So, yeah. One last little fun thing to think about, because you hear me keep talking about an audio processing computer, a codec computer, a telephone hybrid computer, a mixing engine. Well, you're thinking, well, Bill, there's a lot of computers there. That's filling up my rack just as much as all these other things that we're getting rid of, right? Not true. If you've followed the IT world at all, you've heard of virtualization, right? VMware is certainly a big name in that, but there's others too. And what those are arrays of servers and of hard drives that are running what's called a hypervisor on top, and instances of different operating systems running different applications all at the same time in a much smaller box. And to, you know, shared CPU.
Microservices.
So, and in fact, a lot of cloud hosting providers are virtual machines. So, I mean, say hello to your new technical operations center. That whole rack just turned into a bunch of hard, you know, RAID array or hot swappable hard drives with a multivisor or hypervisor running over, you know, and there's backups for those as well. So the hypervisor alone can't fail and take you down. From what I understand, there's a couple of those running in parallel. And you know, if you have an app or hard drive crash or an app gets buggy, it just fails over to the next one. I mean, this is kind of futuristic. This is stuff that's still being architected and figured out. So this is not available today. I mean, that box is, but you know, it's not going to be running software that does what you need. But this is very much something that I think you can expect where it's going. Sadly, that means fewer blinking lights. So, you know, it's always fun to take people into a studio or a control area and show all these boxes and lights blinking, but, you know, I'm sure somebody will sell boxes that have fake lights in it that you could just, you know. So, yeah, okay, there's a market right there. So, I promised I was eventually going to recap, right? So, just consider software in IP transport is what makes it possible to move to a virtual environment. And why do you want to move to a virtual environment? More resiliency, easier access to route audio around your station or the world, and disaster recovery becomes a lot easier. It's more seamless across the different types of audio that's flowing around there anymore. If you don't have to always like, is that analog? Is that line level? Is that AES3? No, that's MADI. No, just put it all over IP. It's done. And the hardware is cheap. I mean, the IT, comparatively speaking, it scales very cheaply because it's already been out there for decades in the IT world. So there's reduced cost and complexity, and because these are all running instances of software, you can access it remotely at 3 in the morning without getting in the car and driving into the studio, which everyone loves to do, right? So thanks very much. That is the extent of my presentation. So if you have any questions related to this, please let me know. Otherwise, I know that the next plan is to kind of broaden the topic a bit. So
I think we'll give you a little thanks first.
oh, okay. Thanks. Thank you. Bill.
Bill, one question back to the closet voice booth. Did you use a mix of polyester, cotton, and wool to do your voice?
Out of your entire presentation, that is what Bill.
No, but you raised an interesting question because polyester acoustically is probably hotter than cotton, right? And I do have a lot of hoodies in my closet, which are thicker, softer cotton, so that's probably more plush and probably more low-end deadening.
And you have to be careful during the seasonal changeover from winter to summer clothes in response to the mood changes.
Oh, that's a really good point. Good point.
The virtual closet.
Well, finally, don't forget the mothballs and everything.
And you have to get all the white out after Labor Day.
You know, I shouldn't have brought up the closet, but no, yeah, I'll have to get back to you with the EQ curves. Maybe we need like a white noise generator and do a couple of tests and see where the, so.
What is WWWR3S?
Oh, actually, I'm glad you asked, because that means I get to show you one more slide. Sometimes in Q&A, people are really curious about some of the virtual software stuff, and now that my presentation is done, I can tell you, you can actually go to Lawo's website, r3lay.com, and download some of everything that I showed you is made by their own manufacturers. So you'd have to, the sites that I mentioned, you'd have to go to their manufacturer sites to download them, but if you wanted to download Lawo's, the virtual mixer, the virtual patch bay, the virtual sound card, those are all free demos. They just time out after 15 minutes.
I didn't get paid to ask that question.
But I do owe you beer now, so thank you. So, but you know, r3lay.com, that's a 3 because it would cost too much to buy the E. So flip it around, save a lot of money. You know, that's how the marketing people think. So anyway.
Well, I mean, that's interesting there, just an example of virtualization and the power of it, that you can demo this
Yeah.
equipment without having to ship it in, without having all that expense. You get to use it for 15 minutes for free. And
So
off you go.
exactly, you can download the stuff. You have to create a free login and add it to your cart for $0. You'll see if you do it. But each one of these, after 15 minutes, get a little white noise injection in it. All you do is close the app and restart it, and you get 15 more minutes. So, you know, if your show is under 15 minutes, you can do the whole thing. But you can call up that mixer and mix. And the thing is, you can flow, if you download 2 of these, hook it up on 2 PCs in your home tonight, you will be flowing AES 67 audio from one computer to the other before you go to bed. So just don't call me for troubleshooting. So.
Any other specific questions for Bill before we move along?
Nope, all right, cool.
You can
Thanks.
tell Bill's been giving this presentation at radio stations and broadcast groups all over the country, and you've done it a few times because I thought it was really smooth
Yeah,
and
he's got it
really
down.
good. So yeah.
Was it too calculated and
No,
smooth?
that was great,
Because sometimes there's that danger of it being too.
No, and while
Thanks.
Bill's presentation is kind of radio oriented, we wanted, and we're here in a radio station. It's so great to see, you know, independent radio alive and well and living here in Pittsburgh and all over the country. And you know, from a lot of articles I've read, you know, just recently, you know, radio is on the upswing as far as popularity goes, and it's going to enjoy an even better comeback than it already has. But while this is kind of radio related, we wanted to open up a discussion about virtualization in other areas of the media world. And I don't want to, this isn't an actual presentation I'm going to give. I want to leave it up to you all. I don't know much about it. So this is an open discussion for the group, and I thought that we have people from all different areas of technology in the media industry here, and I'm sure that there are several people here in the room who have some stories or some information about how virtualization is being used in their segment of the industry or your own facility, your own company or whatever. So I just want to kind of leave it open. Or we could have open questions. If you have a question about virtualization, about what it all means, I'm sure there's probably an expert here in the room that could answer your question. It won't be me. But just wanted to kind of open up the floor to an open discussion on this. So if anyone had anything they want to start with, you know, something about what, yeah, you want to do something? Yeah. I'm just going to ask you to hold this so we can hear you.
I work in audio post-production for video. I work in Pro Tools. Pro Tools is virtualization. Everything happens in the box. My way of connecting to other studios has been ISDN. I now use Source Connect on a daily basis. I've been using it for about 10 years. I now do surround sound mixes across it. Just recently did that for the television show Gone. They played the surround sound mix from LA so the producers here could hear it. We did it across Source Connect. You know, use time code across it as well. Do ADR. So talents here in Pittsburgh, they're recording it out in LA across Source Connect. Now, no, because the video isn't running across it. We're running time code, so the video is living in each place. So we run the time code across, so when I hit play on my box, their box then syncs to it. But you're running across a stereo connection, so between your audio and your time code, there's a delay, but it's the same delay on both channels. So you don't have to worry about it. The only time you have to worry about it is if you get the slap back from your talk back. back to you if they don't route it correctly.
What Sean's talking about here is fascinating. Sean and I work together at PMI, and it's fascinating to know that there was a group of people in our audio studio that were basically attending a mix session at a Hollywood soundstage.
Yes.
Yes, across the country, and they're here in Pittsburgh.
Yes.
Yeah, actually producing the series,
Jeez.
but they were able to attend the live mixing session
Yes.
while they were here.
Yeah, so they made real-time changes, and we could listen to those. The quality, obviously, there's a little bit of quality difference when it comes to the IP stuff, but when you're just doing voice, it's very unnoticeable. With the mixing, they sent me the original mix of the show, listened to it, then they'd listen to that for just the changes, so the quality wasn't as important at that point. I haven't had an actual analog console in my room now for about 7 years. So this is happening. It is real. I now run a lot of my stuff off an iPad so I can move around the room while I'm mixing. So I'm not attached to that mix position, and that comes in extremely handy when I do film work because you kind of have to move around your room because not everybody in the theater is sitting in the optimum position for listening. So you do want to make sure your mixes sound good. So I can actually now, I used to have to do Foley on my own, so I'd have to hit play and record and then run into my recording space. I can now take the iPad with me and control Pro Tools from wherever I am. So it is a real thing. It's happening, and it's happening across, Source Connect now actually does have streaming video software. It's not quite there yet, but they are trying and they are working on it. So I can tell you a little story in the other world. If you guys go to Penn's games, Ryan Mill is the man who does the announcing at the games. Last year, he did one of their preseason games while he was on vacation in North Carolina. So he hooked up via Source Connect where he was in his hotel room or condo and announced the game.
And he watched the game and talked.
No, they were just IMing him what was happening. So he didn't even see it. Yeah, he was just reading off of, yeah, so, but yeah, I mean, that's literally what you can do, and I've been working with voiceover talent for the commercial work that I do that basically set up small studios in their home, a closet, but they work out of their home. That way they don't have to travel at all, and they can do more work per day, not having to travel to studios, and at a lower cost, and now they can work all around the world.
And then everybody's kind of using the same app.
Yeah, pretty much. Source Connect is the main one. Source Connect also has where it's just Chrome-based. It's a lot lower quality, but you can just do Chrome. It's connection through Chrome. There's a lot of people that use that for their guests, for their radio shows, because you just need a microphone, plug it into your laptop, and there's tons of those out there now. I don't know if it works on the phone yet. I'm not sure. You'd have to check on that. I know IPDLT, which is a European company, does a similar thing. I don't know if they have. Yeah, I'm not sure if they have that yet. I know there are people that are making apps like that. So, yeah. Yeah, I've done a few sessions with that. Yeah. No. So, yeah, I mean, this is the world we live in now is pretty much this in terms of working that direction. So,
I was going to ask you to share if you did it on your own, so I'm glad you did. Anyone else have anything, examples of virtualization or?
This is not audio, it's video, but and I think this is the same thing. Our cameras are usually controlled by a remote control panel, which is like $5,000, with a joystick and all the buttons and knobs and menus and LCD. We now use ROS Dashboard, which is a virtual remote control, and it's connected via IP to the CCU of the camera, and it runs on a Microsoft Surface or any PC. The Surface tablet is nice because it could be Wi-Fi connected and you could roam around. You could be at the camera at some distance from the CCU setting it up, and so that's a level of virtualization too.
A lot of audio engineers for live sound do that now with tablets running around the monitor mixes on stage.
Yeah.
Yeah.
We talked about that a
sec. I do location sound recording, multi-track recording work and whatnot, and I've got some Yamaha TF series and my recent purchase, a Mackie DL32R, which has great sounding preamps in it, 32 channels in your MacBook Pro, and away you go. And it's very